Okay, so in front of you, you've been given two samples. Okay. So what I'd like you to do, maybe Francesco, yeah, start, yeah, you start. Get your rose fluorescents and put one drop in each container. One drop in each container.
You ready? You watching?
Oh, we have to watch. Hold on, just give it to them.
Yeah.
One drop in.
Annie, if you... Yeah. Get rose fluorescents.
Get rid of this, huh?
Oh, it's going to be filled.
One in each hand, yeah, one by one, yeah, and compare the smell of the two. Yes. So, which is strongest? Okay, so what's happening? Is the oil sunk to the bottom, or is it actually just mixed? It's mixed. So what's happening? We don't smell the perfume, we smell the headspace. So what's happening? It's trapped it, yeah?
Yeah, it's trapped it. Kind of went in and it's kind of all around it. So the water, it's kind of sitting on top because it's an oil.
Yeah.
So it's more.
So it's a lot weaker. Feels a lot weaker. Yeah. So could you now add enough rose to the oil so that it's the same strength as the water?
Is the rose oil heavier than oil?
No. It'll mix with it.
You watch when it goes in.
Yeah. Well, yeah. Try one at a time at first, but you'll need a lot more than that.
Is it that it slows down molecules?
Yeah. So that in the headspace.
It's just trapped.
Yeah.
It's heavier.
Yeah.
Is it to do with the molecular weight?
Not to do with molecular weight. Oily dissolves in oil or doesn't dissolve in oil.
It's basically because the oil is floating in the water, so you can smell it better.
Yeah, and you get better release. Yeah. So what I'd like you to do now is, can you add enough rose to the oil one so the strength is the same as the water? Yeah.
In the water it is coming out
Yeah.
more. So you're saying is that that's because it's floating on the surface of that and it's actually
Not-
mixed in with that, or is that not it?
Yeah, that's part of it. But it's actually to do with release of. Yeah. So I'm going to ask you another question after you've got the strength about the same.
The oil. Is there other things interacting with the rose? With that mask?
The oil is just trapping it. The oil is just trapping it.
That make it.
Yeah.
Where water is doing nothing.
Yeah.
Just keep on adding, or just keep on adding. Where's the control?
How many are you up to now? Keep going.
So that's 10 times water.
You're up to 10 drops now.
10
Yeah.
times the water, yeah. Still nothing.
Totally 6 wickets, no? I reckon
still-
1 plus 5 actually. So it's
No, you
5.
put,
So you put 4 on top of the 1.
I think 7 does it.
I put 2 and then I put 2.
So you put 4, so it's 5 in total. You put 1 in total, 1 in first. So 5. So 5. So 5. So do another 3 more. You need another 2 on top.
Why don't you pour in this and then you will make it? The point is the more nothing's happening to it, is that what it is?
It's happening to it, just not quickly enough.
What's
I've added
it's holding it down? It's not getting into the headspace.
Time thing?
Sorry?
The time thing?
No, no, no. It'll never get in there.
5
So,
plus 3, 8. Add 2 more. 10.
What's the chemistry behind it?
well, that's what I'm going to talk about in a minute. Yeah, but I have to ask you another question first. When you got them the same thing.
See, odor thing.
GCO, not GCO. No.
You know where you can put a flower in it, that shuffle.
Oh, I see. Headspace analysis. No, 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 no.
Go
Yeah, I mean it is good because it tells you what's in the headspace, which is what you smell.
I mean, they use it for, say, flower hair.
Yeah.
You guys have a machine in your place?
No. We
You don't do the stuff?
because it's we can use some of the best brains in the world. Yeah.
You guys don't do.
And we don't have to do the hard work. No, if we did hundreds a month, if we were doing it continuously, we would buy our own machine. But because we only do like 50, 60 a month,
It's like an expensive machine.
yeah, it's about $100,000.
It was about 200. Probably 150 with the software, there's that.
Yeah.
Because I get a lot of people obviously asking about, making oil-based and solid perfumes and that kind
Yeah.
of thing. And I've not really sort of delved into the science behind it, but I know that like top notes don't really work, and you've got to really use a lot of the heavy
Yeah,
bass
yeah.
balsamic,
Yeah.
because they're the only things that really work. But even they don't lift up in the headspace.
Right.
You've got to get
Yes. Yeah. Yeah.
with synthetic, is that just because it's naturals, or can there synthetics that you can get a lift out of an oil base, or is it just the nature of the base?
Nature of the base.
So whatever you use, whether it's natural or not, it's going to be difficult to get a lift into the headspace from an oil or a
It's going to be more difficult than for a water-based product. Yeah. Yeah. So how many did you get to? Are you there yet?
10 drops.
Sorry?
10 drops and it's still about like 1/5 or 1/3.
So try 10 more.
She feels like she's wasting
No, but you'll remember the lesson, yeah? You remember the lesson. How many are you up to?
50 now.
50. Yeah.
We in the lead?
Yeah, you're in the lead, I think. This table are up to 50 now. How many are you up to? Sorry? 25. Be bold.
Be bold. So we can do another team? Yeah, do another team.
What like now that 10
25.
واحد اثنين ثلاثة أربعة only four خمسة ستة سبعة ثمانية تسعة
How many drops so far? 30? Close or?
I don't remember.
Can I smell? Can I smell?
I don't remember.
Okay.
We can do it.
So my next question to you is, if the strength is now quite close, is it the same smell? So let's have a smell. Let's have a smell, because
Let's let 70 is still not is not
Give it to the master.
careful.
okay, we might have enough now.
Don't drink, huh? Not allowed to drink.
I think we've got enough now for the next question. Assuming that the strength is now sort of comparable, is it the same smell?
No.
So it's a different smell as well.
Yeah.
So it's
I
not.
don't think it'll even be the same smell, will it?
No.
No. So,
Why not?
because oil smells.
It's come same smell, but
No.
There's an aroma.
No, it's nothing to do with the oil. Smell of the oil. Nothing to do with the smell of the oil.
What's the? It's never
No.
going to smell.
Sorry?
Just put 35.
Yeah.
It's never going to smell. the
They're
same.
up to 70.
So I mean, it's never going to happen.
But they put 70 drops.
So that means there's nothing. To
So let me.
You'd need about 150 to
just mix that.
anywhere close.
Okay. So my next question to you. Let's give me another. Give me some more. Let's put another 15 in there to get. We'll probably run out of material. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Scientifically.
Yeah.
Some water in there.
Okay, let's assume we're not going to get there. But so my next question is, are they the same smell?
Sorry?
Is the smell the same, just weaker?
No, it smells the same.
No. Oh, okay, so the more volatile components are being held.
Not volatile. It's not volatile. The answer is not volatile. So the question is, so let's say we may never actually get there. Yeah. Is the smell the same, even if the strength is not the same? It's a different smell as well. Okay, so what's happening?
Some bits are dissolving to others.
Good. Yeah. So, is it the same smell? No. So what's happening?
The smell of oil. You can smell oil.
You can actually smell oil as well, but even the perfume doesn't smell the same. Why not? Okay.
5556666.
So, okay. So, most of you agree that not only do you need a lot more of the perfume, that even after you've got a lot more of the perfume, the smell isn't the same. So, what's happening?
Smelling the oil.
No, it's not so much smelling the oil. That's an aspect of it, but it's not really what's happening. What you're getting is something they call in chemistry partitioning. Yeah. Now, if you imagine that your perfume, contains phenyl ethyl alcohol, 20%, citronellol, 20%, geraniol, 20%, maybe I'll make that 30% just for ease. 30%, 30%, 30%. And phenyl ethyl acetate, 10%. Which of these is the most soluble in water? The first one. This is about 2.5% in water, soluble in water. This is only like fractionally soluble in water, 0.1%. This one is only 0.1%. And this one is not soluble at all. Yeah? So what happens to the headspace? Each material is attracted or kept back by the water according to its solubility characteristics, but not in the same amounts, because this one will be held back completely in water, this one will be held back slightly in water, this one will be held back slightly in water, this one will not be. So phenyl ethyl acetate has like a stronger, fresher note. So in the water, the phenyl ethyl acetate escapes completely with some of the geraniol, some of the citronellol, but none of the PEA. So the PEA gives this roundness. Yeah. In the oil product, yeah, the phenyl ethyl acetate is completely oil soluble. This slightly water soluble fraction lets it push out of the oil, and the PEA can push out of the oil too. So you get like a round, flatter rose, but you don't get the freshness. Yeah? And this balance of oil and water, the hydrophilic, lipophilic balance of a product, yeah, changes how the product appears. So if you get a shampoo and a conditioner, the shampoo has products there for cleaning, the conditioner has the cationic surfactants, but usually also has some oil base to hold it back. So many companies use the same perfume for the shampoo and the conditioner, actually. But they smell quite different when you put them in the products, because the perfume is partitioned. It doesn't release the same way, so you get a different smell in the product. Yeah. So when you're developing your perfume for a product, yeah, you have to look at how the base holds the ingredients back of the perfume, and then either increase them if they don't get released well, or replace them with something similar that releases better. Yeah. The mechanics of doing that we do next week, 2 weeks time. Yeah, but all of you finish today, when you're doing your perfumes for different bases, try the ingredients in the base to see how they work, and then adjust them accordingly. Yeah. Okay.
So it's kind of the opposite to how I was thinking. It was like the oil doesn't necessarily trap the fragrance back.
Yeah.
It actually lets a lot of it escape. Like the fresh bit
Yeah.
is escaping.
Different parts of it. Yeah, different parts escape.
Okay.
Escapes it. Yeah, different parts of the perfume escape
Which is why you'd never be able to get the same fragrance
in two different bases.
perfume and
Yeah,
alcohol-based
yeah.
perfume, because they would let different bits
Yeah.
go.
Why wasn't it smelling in the oil initially?
Well, because essentially the perfume is oil soluble, generally, so most of it is trapped anyway. Yeah, most of it is trapped anyway. And then after that, you also get this fact of some of it can be released, some of it can't be released. Yeah. If it was perfectly soluble, then you would get no smell ever. Yeah. Yeah. Any product that is the perfume is like 100% soluble will get trapped, and you won't be able to smell it from the product. Yeah. You might be able to smell it on the skin because then it would evaporate from the skin, but you wouldn't smell it in the product.
Is there any difference if I would add the oils in water and then mix them together using a solubilizer or something?
Yeah, the solubilizer will change the hydrophilic lipophilic balance. Yeah, and the problem with if you try to solubilize a perfume, if you over solubilize it, the smell disappears. Yeah, flattens and disappears. So you have to get it just right so you get release. Yeah. So in your products you have to bear this in mind.